Okay, so today we're going to briefly go through the chain rule. And the chain rule, you're going to work with the chain rule when you have a composite function, meaning one function is plugged inside the other function. So all you need to do is take the derivative of the outside function and then leave the inside function alone, and then take the derivative of the inside function. Let's try the first example. Find the derivative of y equals the quantity x squared plus 1 raised to the third power. So first we have to identify what is the outside function. And the outside function is just this thing raised to the third power. The x squared plus 1 raised to the third power. And the inside function is whatever is inside the parentheses in this case, which is x squared plus 1. So when we take the derivative, look at the outside function, we have to take the derivative of that first. So you just bring down the 3, and it's 3 to that function raised to the second power. And now we take the derivative of the inside, which is just 2x. What goes inside the parentheses? Well, it's the inside function, and we don't ever touch that. You're done. All you have to do is clean it up a little bit. So multiply the 3 and the 2x together, and you'll have the derivative is 6x times the quantity x squared plus 1 squared. Let's try another one. If you think you understand it, put the video on pause and try it. Otherwise, we'll work through this one together. The outside function in this case is that parentheses raised to the third power, and the inside function is going to be whatever is inside the parentheses. And when we take the derivative of the outside first, it's 3 times the quantity 3x minus 2x squared to now raised to the power of 2. Notice I didn't touch the inside, and now I have to take the derivative of the inside, which is 3 minus 4x. And again, you're done. You just need to clean it up a little bit. In this case, I'm going to multiply the 3 and the 3 minus 4x together, and I'll have my derivative as a quantity 9 minus 12x times the quantity 3x minus 2x squared squared. Notice you do have to put the parentheses around the first two terms because you're multiplying that entire thing by the second term. Find the tangent line to the graph when x equals 2. And the graph is the cube root of x squared plus 4 squared. So right now it looks a little daunting, but let's rewrite it first. You should remember that when you take the cube root of something, it's the same thing as to the 1/3 power. So if something's squared to the 1/3 power, it's going to be that something to the 2/3 power. So now it looks a little bit easier. The outside function is that something raised to the power of 2/3. The inside function is x squared plus 4. Maybe you should pause the video and try taking the derivative of it. And the derivative is, you bring down the exponent, 2/3. The inside function stays the same first, x squared plus 4 raised to the, and 2/3 minus 1 is negative 1/3. The inside function, the derivative is 2x. I'm going to just clean it up a little bit, make sure that any negative exponents gets moved so that they become positive. And we should remember that, again, anything raised to the 1/3 power is the same thing as taking the cube root. All right, so we took the derivative. We're basically done. We just have to answer a couple questions. When x is 2, what is y? And when x is 2, the slope would be what? And then finally, the question asks for the equation of the line, so we're going to have to figure that out. When it says x equals 2, what is y? What they're asking is for you to plug in 2 into the original equation, not the derivative yet. We need a point. We need an x and a y value. So if I plug in 2 into my original equation, 2 squared is 4. 4 plus 4 is 8. You can take the cube root of that first, which is 2, and then square it, which is 4. Or you can square it first, which is 64, and then the cube root again is 4. So either way, I have the point 2 and 4. And that point 2 and 4 is on the graph. Now I need a slope, and we took the derivative and found the equation to the slope. So we plug in 2 into the derivative, and we find that the slope is going to be 8/6, which when you simplify, it's 4/3. So now we have a point, 2, 4, and we have a slope, 4/3. You should be able to write the equation. So the equation is y equals 4/3 x plus 4/3. So that's the equation. The purple is the graph of the original function. The Tangent line to the graph is right here, 4/3 x plus 4/3. And you can see the yellow dot is the point 2,4. That's where we want the tangent line. The interesting thing is that this equation to this line here, it only is y equals 4/3 x plus 4/3 at this one point. If I move the point to the right or left on the purple graph, the equation to the line changes.